Hello, this is team member Janae, and I will be going over the first part of our presentation, which is the project plan. Before I begin, I want to announce our other team members, which is our leader, Ryan. We also have Justin, Milo, Josh, Tyler, and me, of course. So, for our project goal was to create a functional desktop application that allows customers to create accounts, build pizza orders, choose payment options, and receive receipts. The system will be using a clean Java FX interface and Java as the development language. The app simulates a real pizza ordering environment with customers recording and menu items. So I want to also go over the scope. The scope of our project includes things like planning, UI, prototyping, requirements, documentation, system design, coding, testing, and of course, by organizing the scope this way, we wanted to ensure the team can move step by step from our early planning all the way to integrate and working for our product. Now, our work breakdown structure was divided into 6 major phases. So, of course, we had the project planning phase, then we had the UI mock-up requirements, then we went over to the system design, coding, and then, of course, we had our final presentation. So each of these phases contain details, tasks like creating the diagrams, building the prototype, implementing logic, integrating the database, and testing, which in the end, it helped us be more efficient in our project. So we also had our team roles to stay organized, and we also had specific roles, of course. Like I mentioned earlier in the beginning of this presentation, Ryan was our team leader, Justin was our lead programmer, and Milo was leading the document writer. Josh also handled the organization, and Tyler was our QA engineer who focused on testing. And I, of course, served as the project manager to keep the project on track. Now I want to go over the technical descriptions. So, like I also mentioned again, the application is built in Java using Java FX for the graphical interface. Customers would be able to log in or register and view the menu, build their order, and enter payment information. The system stores encrypted credit card information and uses a database to manage customer records, menu items, and order history. We also included restrictions relative to privacy and encryption. So the core of our functionality includes creating new customer accounts, editing records, and recalling customers by phone number. Our customers would also or can build detailed pizza orders by choosing sizes and like other things like, crust, toppings, and beverages. They can select delivery or pickup, and the system calculates total automatically. We also had multiple payment options, like cash, credit, or card. They were all supported, and the receipts are stored to the customer record. Managers can also edit the menu item and view all customer information except passwords and payment details, of course, because we don't want them to access that. And okay, so for our data management plan, the data management plan was to define like who can access what. So like I mentioned, customers can edit their own data and see their store information. Managers have more access. They can view all the customers' profiles, minus sensitive payment data, and can edit or update the entire menu. So that's a controlled access, which would help maintain security and privacy. Um, we also had a testing approach. So our testing strategy included unit testing individual components, integration testing to verify module work together, and system testing for full end-to-end functionality. We also performed a non-functional testing to check performance, accuracy, and reliability. So all of our tests occur in a controlled environment with test database and payment data to ensure safe evaluation. We also considered the system ready for delivery when all high severity defects are resolved and core features like, for example, customer creation, ordering, payment, and the receipt printing were all functional. So in the end, finally, users' acceptance testing will confirm that the system meets the client's objective and performs as expected. And that is it for our project plan part. We will be moving on to the next member. Thank you.
Hi, I'm Milo, and I'll be walking us through the user interface for our first prototype, demonstrating the core flow of the Pizza Parlor application. We begin here at the login screen. This is a secure entry port for the application. Existing customers enter their phone number and password to log in. New users can create a new account, which redirects them to the account registration page. This is the account editor. Here the users can manage their personal profile. This includes inputting the delivery address, city, state, zip, as well as entering specific delivery notes for the driver. This screen also handles credit card information, allowing the user to save payment methods for faster checkout later. Once logged in, the user lands on the welcome screen. We wanted a clean landing page that immediately prompts the user to create an order or to access the main menu. Clicking Create an Order brings us to the main menu. This serves as a central hub where the user can navigate to different categories, such as beverage, cart, or pizza. You can also see a running order summary to the right, which updates the subtotal in the real time. If the user clicks pizza on the main menu, it takes them to the pizza selector. Here the user is presented with options to choose from, various pre-made pizzas, or they could choose to build their own customized pizza from scratch. Once a selection is made, we move to the pizza editor. This allows for full customization. The user selects the size, such as small, medium, large, the crust type, thin or regular. They also can toggle specific toppings like pepperoni, sausage, and even add special instructions for the kitchen. When the customization is complete, you can click Submit, and it adds the pizza to the cart and returns the user to the main menu. If they navigate back to the main menu and choose beverage, we see the drink selector. Users can choose from various brands like Coke, Sprite, or Mountain Dew. We've included options for single sizes all the way up to 2-liter bottles and gallons for larger parties. Just like the pizza editor, by clicking Submit, adds the drink to the total and sends the user back to the main menu. When the user is done adding items, they click Cart button on the main menu and it takes them directly to the payment options screen. Here they can review the final order summary, including delivery fees and local taxes. They can toggle between delivery or pickup and select their payment type, whether it's cash, card, or check. Finally, after the payment is processed, the system generates an order receipt. This provides an itemized list for the purchase, confirms the delivery address, and provides a signature line and space for a tip. The user can then print this for their records. This covers the primary user flow for Prototype 1. Thank you.
Hi, my name is Tyler Brown, and in this section, I'll be covering the requirements portion of our project. The purpose of this milestone was to define what the system needed to do before we started designing or building anything, and it acted as the foundation for our entire project. This was the stage where we focused on understanding the customer's needs, clarifying the system's behavior, and making sure our team had a shared vision. For this portion of the presentation, and since this document has already been submitted and reviewed, I'll be giving a high-level overview rather than going into every individual requirement. My goal here is to explain its purpose in the project and how it guided our later work. So, from a high level, the requirements segment of this project answered 2 important questions. The first one being, what should the system even do? And the second being, what constraints or quality standards does it need to meet? So, we covered the core features, and for example, creating accounts, placing orders, customizing pizzas and drinks, handling delivery, processing payments, and generating receipts, for instance. These are the essentials that make up the user experience. Then we outlined the non-functional requirements, which described things like performance, security, and reliability, essentially the qualities that make the system feel smooth, safe, and dependable. As far as our approach to the overall experience with this milestone, putting this document together required us to think carefully about the system from the user's perspective. This meant breaking the project down into clear, organized sections instead of jumping straight into code. In a lot of ways, this part of the project felt like stepping back and building the blueprint before picking up any of the tools. One thing that we noticed, or well, acknowledged collectively during this milestone was just how much detail goes into defining requirements. Even simple features like logging into the system or, for example, adding a pizza to the order can often gets broken down into many smaller steps, conditions, interactions. Getting all of this written out early prevented a lot of confusion later on and kept our team aligned as we move forward. Because of that, the requirements doc ended up being a valuable resource for all of us, and it played a huge role in shaping the rest of our project. It guided, our design decisions. It influenced how we structured our diagrams, especially later on in the project. It made the implementation phase much smoother because the expectations were already clear. All of the later stages, the prototype, the system design, UI screens, database logic, and even receipt generation, they all tied back to what we defined here. It served as our reference point, and anytime we weren't sure how something was supposed to behave, we could return to the requirements to confirm the intended flow. So overall, laying out the requirements in this document helped us start the project with a clear roadmap. It established the scope, the goals, the constraints, and set us up for a much more focused and organized design phase. With that foundation in place, I'll now pass it over to Josh, who will take us into the system design document and cover the next stage of our project. Thank you.
Hello, this is Josh here to share a little about our system design document. We'll take a brief look at report formats and screen layouts, since you'll be seeing those things in action later in the video. We'll spend a little more time on the technical design aspects, including info about the classes, database, and technical support. Now, our one report format that we had was the order receipt, which you can see here. Items are listed alongside their cost, subtotal below the line, then added up with the delivery fee and tax to find the total at the bottom. Now, moving on to our screen layouts, we'll look at a few of these here. So first, of course, we have the login screen, where they'll log in with their phone number and their password. They can also create a new account from here if they don't have one already. If they do that, they'll go to the account editor screen where they can add or edit whatever information they need to regarding their account and then save it. And then once they're logged in, they'll come to the welcome screen, which really just greets the user and gives them a chance to start their order, which will bring them to the main menu where they can add new items to their order, as well as view items that are currently in the order already. If they choose to add a pizza there, they'll go to the pizza selector, where they'll add either a build your own pizza or one of the specialty pizzas. And from the pizza selector, they would go to the pizza editor, where they can choose the size, the crust type, and add any additional toppings they might like. And if they'd added beverage instead of pizza, they'll select quantity, size, and flavor of beverages and then add those. Once they've added everything they want to add, they'll get to the cart, which is their opportunity to update payment and address information and double check their order before submitting it, which will bring them to the order receipt, which really we've already covered. Now, moving on to the technical design aspects. First, we're going to look at our detailed class diagram. Now, that covers our classes and their parameters and methods. We can see that all the classes ultimately relate back to the user class, either directly or through the order class. Now, we'll look in a little more detail here. In the supporting text specification, you see we've got class names and all of their parameters and methods with a little bit more of a description as well. We get along to pizza, which we will use as an example. You can see you've got the class name there, you've got their fields or parameters. And then after that, of course, we have methods. Now, there are mostly constructors and getters and setters here, but there are a couple of different methods where you can add or remove a specific topping to the array list, which acts as a parameter to the pizza class, the pizza object. Other classes that do basically the same thing. All right, now following that, you can see our database table description. Here's a list of all our attributes, along with their data types in SQL and the associated variable name in the platform. We can also see the description of screens in the platform where this data can be interacted with. Login screen, account editor, and payment option. Now, we did end up using only one table for users, going with the idea that anything else like menu items will be hard-coded into the platform, as will be covered here in the technical support specifications. Here we simply describe how the tech support staff will assist with installation, training, and updates, which would include any menu changes. And this is how we documented our system design, and I'll go ahead and hand it off to Ryan to go into how the platform itself functions.
Hi, I'm Ryan. I'll be explaining how we structured the PizzaTime application using a model view controller design pattern and how the different parts work together to create a seamless ordering experience. Our application is built using the MVC pattern, which organizes the project into 3 clearly separated layers. Model represents business data like users, orders, pizzas, and beverages. View, all FXML screens, UI components, and CSS styles. And controllers, bridge between user actions and business logic. This prevents UI changes from breaking backend logic and keeps the code modular for future expansion. Additionally, we included a database to store persistent application data using JSON and a text file, which we'll go over in further detail later. Before we walk through the app screens, I want to point out our responsive UI. Layouts dynamically resize and position themselves based on window size. Panels scale proportionally using property bindings. Hidden panes are not managed so they don't leave empty space. This ensures the app remains clean and usable whether the window is minimum size or fully expanded. Now let's go over each screen and its functionality. We'll start at the login screen. The user will log in with their phone number and password. The password input is securely hashed using PBKDF2 before comparison. A successful login sets the active user in user session singleton. Simultaneously, a new order object will also be created, which will contain an observable list of type order item to store pizza objects and an observable hash map of type beverage to store the beverages. Each FXML page, which functions like an HTML page for Java UI, will be connected with an associated controller Java class, and the navigation between UI screens will be handled by a scene manager, which will load each UI FXML screen into a primary container. Next, we have the account editor screen. A highlight of our system is the use of forms. The form class allowed us to easily transfer data between text field and object creation. Additionally, we binded the text field with the form to update whenever the text field is changed. Dynamic validators have also been implemented on most text fields. We allowed text field validation to be dynamic in their use case, allowing them to only be required when the field is visible. When pre-existing data is needed, it will be loaded into the fields using the associated form class to auto-populate the data. Lastly, we implemented custom drop-down menus for card type and state data fields, as well as added automatic formatting to certain data like phone number and expiration date. You can see at the bottom of the screen that in order for the submit button to be allowed to click, you must enter all data properly, and validations must be accepted. We have logged a user in, created an order object, and have now reached the main menu. This is the central navigation hub for the user. The 3 primary buttons are Pizza, which allows the user to add a pizza, Beverage, which allows the user to add or subtract beverages from the order, and the Cart, which will bring the user to the payment screen. To the right of those buttons is the order summary, which will display all of the current items in the order, including the subtotal. We created a separate component and controller to handle the order summary since we used it in multiple locations of the application. In the upper right corner, the user can log out or update the account profile. The first item we'll add is a pizza object. The user is greeted with 4 types of pizzas: a meaty, a veggie, and a house pizza. All of these items have a pre-selected combination of toppings, but all options can still be modified. Lastly, we have the BYOP option, or the Build Your Own Pizza, and this option simply provides the user with a blank canvas. Since we now have our pizza selections, we know we will get thirsty. So let's add some beverages. There is a tremendous selection of drinks, and each option uses a stepper to increment or decrement the beverage totals. If you noticed, we have the same order viewer in the beverage screen as we did in the pizza editor screen. We created an additional component that controls the current user selections a user makes in each of the editors. Additionally, we used an observable map to store the beverage selections, so that same map can be reloaded back into the beverage editor each time it opens, so you can edit the order in real time. Now that our order is complete, we realize we only need 3 pizzas, so let's delete one from the order. When the user enters the cart, they can choose delivery or pickup. If delivery is selected, the address form will appear preloaded with the user data. These fields are dynamic, meaning if the delivery is not selected, the field will not be required. However, if it is selected, they are required, but are also modifiable. And if the user decides that they want to save that address, they can click the Make Default checkbox to save it to their profile. The next option the user has is the payment option. If the user selects card, all their payment options, the same thing will occur to the card form as the address form. And on the right side of the screen, you will notice we use the order summary component again. Except this time, when the user selects delivery, the delivery label will be added to the total updated. So let's make our payment and see what happens next. Ta-da! We have reached the receipt. This is the final screen. In order to make the receipt, we created a new component called user info and combined it with the order summary component to construct the receipt. Also, the address used for delivery is stored to the order, so if the user uses a different address than the one stored in their profile but chooses not to save it, the delivery will end up at the provided location. If you look under the receipt, you will notice 3 buttons. If the user wants to create a new order, the user session will create a new order object and return to the main menu. If the user is done, they can click log out and return to the login screen. The user stored in the user session will be set to null, as well as the order, awaiting a new user to log in. And finally, we have the print receipt button. And I'm going to pass the mic to Justin to present the print receipt functionality, the database implementation, and conclude our presentation.
Now, for the implementation of the database, it is structured similar to how the user session is, as it has a singleton design. And we have the singleton design so that we can access the database instance from anywhere in the codebase. Now, in order to read and write to the database, we have the buffered reader and the buffered writer. Now, the data is stored in JSON format, but as a string, as a file, is a text file, as you can see here. In order to get the data into that JSON format, I used JSON to convert a Java object into JSON, and it also converts that JSON into a Java object as well. Now, since it converts it directly into a Java object, I created a user list object that provides that user list, and it also has these JSON conversions using JSON here. So here's the to JSON and from JSON. Now, in order to create the receipt, I utilized Apache PDF Box to create the PDF. As you can see here in this print method, it creates that PDF document and adds all of this components for the format of that receipt. And at the end, it saves that PDF and closes it. And then opens that file that is saved. Now, I used open instead of print, as it would throw an error if the user didn't have any printers set up. Okay, so now I'm going to run the application. Okay, so I'm gonna log in, create an order with pizza. Let's do meaty, submit, and then also have a beverage medium Coke. All right, so once we go to the cart, add a card, it accesses the default card information, set it to delivery. Now, once we submit, here's the receipt page, and if we press print receipt, it creates that PDF as I mentioned before, and from here you can just print it if you would like. And that concludes our presentation for our Pizza Time app. We are the Laser Ninja Eagles, and thank you for watching.